everyone, I'm Nilusri Sengupta, your instructor, and today I will be teaching you the architecture of LLMs. So there are basically 4 layers of LLMs. They are recurrent layer, feed-forward layer, embedding layer, and attention layer. These 4 layers collaborate together to process the inputs that we give and generate our desired outputs. So now let's dig deeper into the transformer-based LLM architecture. So at first we are going to have the input embedding, where a text is broken down into smaller unit, which is tokenization. Then each unit is converted into a numerical representation. Next part is the positional encoding, where transformers inherently lack this order information, so encoding helps the model consider the sequence of tokens during the processing. Encoder-decoder architecture, which is the core component of a transformer-based LLM. So what encoder does? Encoder processes the input units and provides the context-rich representation. Each layer has 2 components, the self-attention and the feed-forward. Self-attention determines the importance of the different words in the sequence and how to relate to each other. Then the feed-forward network processes each word individually to capture complex interactions. Now next we are going to go for the decoder. Let's see what it is. It produces outputs based on the content supplied by the encoder, enabling for a sequence-to-sequence activities such as language translation and summarization. Among the widely known transformer decoder models that are like GPT-3, used for tasks like generating text, translations, and summarizations. So here we can see 3 types of transformers that are decoder only, and encoder-decoder transformer. Next we have the multi-head attention. Simultaneously, transformers use multi-head attention, allowing the model to capture the diverse relationships and attend to various parts of the input sequence concurrently. Next is the layer normalization. It is used after every subcomponent stabilizes the learning and enhances the model's performance across different inputs. Next is finally the output layer that is tailored to the specific tasks, like here we are using the softmax. Now let's understand the transformer architecture types. There are 3 types, that is auto-encoding, auto-regressive, and sequence-to-sequence. Now let's understand the various types of transformer architectures. Number 1, auto-encoding. Number 2, auto-regressive. Number 3, sequence-to-sequence. So here we can check out the difference. That is at first target. Auto-encoding has to reconstruct the input data. Auto-regressive is predicting the next element in the sequence. And sequence-to-sequence is translating between the sequences. Then the structure, it is auto-encoding, having the encoder only, then auto-regressive is having the decoder only, and sequence-to-sequence is having the encoder-decoder both. Next, applications. Auto-encoding is used like unsupervised learning, question answering, then auto-regressive is used for text generation, language modeling, and sequence-to-sequence is used for machine translation, text summarization, and chatbots. Now we are having the examples for each: BERT, GPT-3, and T5 text-to-text transformer. Now let's understand the features of the transformer-based LLMs. At first is the attention mechanism. That is, it helps to analyze the long sequences weighing different words. Then with the self-attention mechanism, each word in a given sequence is attending on other words that helps to understand the relationship and the dependencies between the words. Next is scalability. We can scale the LLMs as per our needs. It can handle large amounts of data. Next is performance. As the amount of data increases, the performance also rises. So all these make it very efficient. Now let's check the factors on which the LLM architecture depends. Number 1 is the model size and parameter count. Number 2 is the input representation. Number 3 is the self-attention mechanism. Number 4 is the computational efficiency. And number 5 is the decoder and generation. If you are interested to learn more about the computational efficiency, you can check out the link below to the computational efficiency video where our expert is talking about it. So that's all for today. Thank you.